This is an instructional video on changing numbers from scientific to standard notation. So going from scientific to standard notation is just the exact opposite of moving from standard to scientific. Remember, in scientific notation, we have an exponent, and the exponent tells us how many times to move the decimal. Don't forget that a big number is represented by a positive exponent. And a small number is represented by a negative exponent. One little more piece of information, and it might not make sense just yet, but it will once we start doing some examples, is that we want to fill any blank spots with zeros. So we're going to write 6.85 times 10 to the 8th in standard form. So I'm going to take the decimal, 6.85, and we're going to move it 8 times. So I take my decimal and I go 1, 2, 3, 4, 5, 6, 7, 8. So the decimal point is now way back here. And this is what I was saying. All of these blank spots at the end, we're going to fill them in with zeros. You cannot leave your answer like this. You have to rewrite it neater. So 685 with 6 zeros. 685 million. Write 9.054 times 10 to the negative 6th in standard form. So again, we're going to take our decimal, 9.054. We're going to move it negative 6. So we're going to move it 6 times forward because that puts the decimal point in the front and zeros in front of the 9054, representing a small number. 0.0000009054. Remember, positive exponents represent large numbers, negative exponents represent small numbers. This negative 6 tells me it is a small number, so the zeros need to be in the front of the problem. Convert the number to standard notation. I take the decimal, 7.83, and I'm going to move it 7 times. It's a positive exponent. That tells me it's a large number. Large numbers has zeros at the end. So 1, 2, 3, 4, 5, 6, 7. We fill the blank spots with zeros. And then we rewrite our answer neatly. 787 and 5 zeros. Convert the number to standard notation. We take the decimal, 8345. We're going to move the decimal negative 6 times. It's a negative exponent. That tells me it is a small number, so the zeros need to be in the front. So we move it 1, 2, 3, 4, 5, 6. Fill it in with zeros. And then we write it neatly. Our decimal point in the front, 5 zeros, and then our number, 8345. Convert the number to standard notation. Take the decimal, 2.5. We have a positive 4 for our exponent, so we know it's going to be a large number. So we move the decimal to the right, 1, 2, 3, 4 times. Fill in those blank spots with zeros. Write the answer neatly, 25,000. Convert the number to standard notation. 3 times 10 to the negative 3rd. So I take my number 3. If there is no decimal point, the decimal is going to be here at the end. We want to move it negative 3 times. Negative 3 represents a small number, so we put the zeros in the front. 1, 2, 3. Fill in my blank spots, and our final answer, 0.003. The size of an atom is 5 times 10 to the negative 5th meters. Express this number in standard notation. So again, we're going to take our number 5. There is no decimal point, so that tells me it's here at the end. And we're going to move it negative 5 times. Negative 5 tells me that it is a small number. Small numbers have zeros in the front, so I have to move it 5 times. 1, 2, 3, 4, 5. Fill in that blank spot with zeros and rewrite it neatly. 0.00005 for our final answer. Write 2.595 times 10 to the negative 2nd in standard notation. So I'm going to take my number 2.595. I'm going to move the decimal negative 2 times. Negative 2 tells me that it is a small number, so we're going to move the decimal forward to put the zeros in the front, and I'm going to go 1, 2. Fill in my blank spot with a 0. Write the answer neatly, 0.2595.